Um, our philosophy with VMX is to be all-encompassing. You can work with your traditional bare metal slaves, your classic render farm, and the cloud, multiple clouds if you want, VM slaves, all at the same time. There's no vendor lock-in. You can choose a cloud provider that best meets your cost and functional requirements. And what that means is that, to contrast a little bit, if there are services where you upload your work and they're like a third-party service that is cloud-based and they do the rendering for you and send back the results. And I think those services are important and provide good value in the industry, but they do come at an overhead. And they also have some limitations in what you can do in terms of pipeline and so forth. So the advantage of the VMX approach is that you can negotiate directly with your cloud provider. There's no middleman fees, and here are the dialogues of Monitor asking for a new account because it's a fresh repository. And so Monitor is going to load up here, and I will switch back. So as I was saying, you can negotiate directly with your cloud provider, and I would really encourage people to look at their choices with cloud providers. There are smaller providers that are probably willing to cut you a deal, or if you really need that, if you're really mission critical with your cloud rendering, then maybe you want to go with one of the big providers. Choose the mix and match that works best for you. And of course, with VMX, there's no restrictions on your pipeline because essentially you're just extending your network out into the cloud, and whatever tools, databases, plugins, whatever you might be using, you can use on your cloud VMs as well. So there's no limitations in that sense. All right, let me see if the Monitor is loaded. It is. So I'm going to switch over to the Monitor momentarily, and I'm going to unsuspend a couple of jobs here. So what happened is the Cloud Wizards went and it installed some infrastructure inside the cloud account. It also set up a repository, and in that repository, it pre-populated some demo jobs. And the idea there is that we want you to be able to actually play with cloud rendering right out of the box without having to wait, without having to configure your virtual machines. This way you can actually see how it works. You can experiment with scaling the number of virtual machines. You can see how the balancing works and get a taste for it without having to do a bunch of configuration. So I'm going to resume these jobs. Oops, I need to be super user. There we go. And I'm going to resume these jobs. And so what's going to happen is the balancer is going to see that this work has entered the queue in the form of resumed jobs, and it's going to start spinning up VMs. And I'm going to come back to that in just a moment. I want to talk about a couple of pieces here first. So inside Monitor, if you choose the Tools Configure Cloud Providers options, this is where you add your cloud providers. Here we're showing our development repository actually, so we have an OpenStack locally in our Winnipeg office, and we have a test that we've set up for our Google Cloud Platform. And you can basically configure the credentials for each cloud provider. These choices will change based on the cloud plugin that you're using, and you can add additional ones. Here's the dialog that let you choose from the plugins that you currently have installed. If you create your own, or if you ask us to add additional ones, those would appear in the list, and you can choose the provider that you like. Now let me talk about the balancer. The balancer is a key part of VMX. What it's responsible for is launching and terminating VM instances in each enabled cloud region based on the demand in the queue and on budget settings, as well as other settings that relate to groups and which jobs can participate in cloud rendering. So here's a image of the balancer UI. You probably saw it also pop up earlier when I was talking, showing the active cloud regions. In this case, in this particular screen capture, it showed Google, and there was a Blender and a Maya group that was configured. And this is sort of a schematic look at what the balancer does. The balancer runs pretty much from anywhere. It's fairly lightweight, doesn't require a lot of resources, although I would recommend putting it somewhere where it has a very good internet connection. And it talks to each configured cloud region and sort of zaps them and says, hey, start up more instances or terminate instances, and it identifies which instances to launch and terminate based on the demand in the queue. And then the VMX balancer algorithm is what determines how many and which types of VMs to launch and terminate, and for each enabled cloud region. And the balancer algorithm is pluggable. So we ship VMX with a default algorithm that's very conservative and only tries to process work if it's sure that there's work to be done and that the jobs will succeed. However, you can use that as a basis for your own algorithm if you want to customize and tie into other decision-making processes that you have within your company. All right, so group mappings. Group mappings are the key to identifying which jobs can participate in cloud rendering, and also which hardware and virtual images are used to process those jobs. So essentially, the way this works is when you submit a job, you submit that job to a group. And there is a feature within the settings that I'll show next that identifies when a job is submitted with this group, use this virtual hardware type and use this VM image, which identifies which software is going to be used. And you can also identify a cost for instances that are loaded with that mapping. And then based on that, if that group has been configured for a given cloud region, VMX will recognize that and it will spawn virtual machines based on that mapping for that job type. And here's the UI. Back in the Configure Cloud Providers dialog, you select your provider or select the region up on the left. You can see that there's a couple of groups configured in this case, Blender and Maya, and here the Maya group is selected. And for that group, we want to use an N1 high CPU 4 hardware type, and we want to use the Maya installed slave image that's been created. We're going to assign that a cost of 1. So each virtual machine instance that's launched has a cost of 1.